5240. Coning is caused by the combined forces of A. Drag, weight, and translational lift. B. Lift and centrifugal force. C. Flapping and centrifugal force. The correct answer is B. Coning in rotorcraft refers to the upward bending or flexing of rotor blades during rotation. It is primarily caused by the combined forces of lift and centrifugal force. Lift is generated by the rotor blades as they move through the air, creating an upward force that opposes the weight of the aircraft. Centrifugal force, on the other hand, is an outward force acting on a rotating object, pulling it away from the center of rotation. When the rotor blades of a helicopter are spinning, lift is generated as the blades move through the air, and centrifugal force acts on the blades due to their rotation. These two forces work together to cause the blades to bend upward, resulting in the phenomenon known as coning. Coning is a normal and expected behavior in rotorcraft operation, and it allows the rotor system to efficiently generate lift while maintaining stability and structural integrity. The amount of coning can vary based on factors such as rotor design, rotational speed, and loading conditions. 5241. The forward speed of a rotorcraft is restricted primarily by A. Dissymmetry of lift. B. Transverse flow effect. C. High-frequency vibrations. The correct answer is A. All modern helicopters have an intrinsic tendency for the retreating blade to stall in forward flight, which significantly reduces their forward velocity. When the airflow over the retreating blade of the helicopter slows down as the forward speed of the helicopter rises, a dissymmetry of lift is formed, which leads to retreating blade stall. 5242. When hovering, a helicopter tends to move in the direction of tail rotor thrust. This statement is A. True. The movement is called transverse tendency. B. True. The movement is called translating tendency. C. False. The movement is opposite the direction of tail rotor thrust and is called translating tendency. The correct answer is B. When a helicopter is hovering, it tends to move in the direction of the tail rotor thrust. This movement is known as translating tendency. The main rotor of a helicopter generates torque that causes the helicopter fuselage to rotate in the opposite direction. To counteract this torque, a tail rotor is used to provide an equal and opposite thrust. However, this tail rotor thrust has a sideways component that causes the helicopter to drift or move in the direction of the tail rotor thrust. 5243. The purpose of lead lag, drag, hinges in a three-bladed, fully articulated helicopter rotor system is to compensate for A. Coriolis effect. B. Dissymmetry of lift. C. Blade flapping tendency. The correct answer is A. A three-bladed rotor system's rotor blades flap upward, accelerating the blade when the blade's center of mass approaches the axis of rotation. The Coriolis effect is what causes this acceleration and deceleration, commonly referred to as leading, lagging, or hunting, in the plane of rotation. 5244. What happens to the helicopter as it experiences translating tendency? A. It tends to dip slightly to the right as the helicopter approaches approximately 15 knots in takeoff. B. It gains increased rotor efficiency as air over the rotor system reaches approximately 15 knots. C. It moves in the direction of tail rotor thrust. The correct answer is C. When hovering, the entire helicopter has the propensity to shift to the right in the direction of the tail rotor force due to translating tendency or drift.